Sure, sure. Thanks. Uh, yeah, I guess just share my screen and get started. Yeah. So is my screen visible? Right. I guess. Yeah, visible. Great. So yeah, I mean, I think that's a pretty good introduction to start with. But it's you know, at the end of the day, I'm just yet another college student. So I want this to be a very informal kind of session wherein I want questions and I want it to be interactive to the maximum extent possible, right? So I would really appreciate it, Viraj, if like throughout, if there are any questions that are popping up or something like that, then you just, maybe unmute or stop me in the middle and then just, all right, yeah, okay, that works for me. Great. Sure, sure, sure. So, yeah, like Viraj said, I pretty much confused. Essentially, I keep going into data science and consulting. So I've done a few internships in both these domains. And essentially, the purpose of this session today is, I hope that everybody sort of comes out with a basic level understanding of what these two fields entail, and then, also how to get internships in them. So again, just a disclaimer, I'm no expert or anything on these things. I myself am a student, like I said. So what works for me might not work for you. You might be knowing more than me, and all those kinds of possibilities are open. But this is just for a general overview. Uh, Please, by all means, feel free to contribute as much as you can towards the end. So I'm going to actually start off with data science firstly, and this is just a general question, and I want you to think like when I say data science, what comes to your mind, right? And because it's just such a broad term. It's a really broad term. It means a lot of different things for a lot of different people. So, for person X, data science might mean machine learning, right? It's using all those fancy models to predict stuff. For person B, data science might mean statistics, using mathematical formulae in order to draw relationships between data. And for person C, it might mean something else. It might mean seeing the data, using pretty graphs and pretty tables and stuff like that. So again, there are different meanings when it comes to this. So I'm just going to give you like a word map wherein essentially you're going to see a lot of these things that came to your mind, right? Data science is about machine learning, data science is about visualization, data science is about building all those fancy models. Data science is a lot of things. So where do you start? Right? Because this is not helpful. This is me just telling you that it's a very vast field, right? And in a very vast ocean of complexity, where do you start? So I'm going to sort of try making this a bit more concrete. I'm going to tell you the 5 steps of almost every data science project. So I've been careful to put that disclaimer there at the bottom. But these 5 steps, essentially, the idea is that once you sort of see a whole data science project from start to finish, you're going to get an idea of what exactly are the steps entailed, what exactly you can be good at, and what's a good place to start, right? So I personally feel that this is a good starting point for anybody who's sort of into data science, wants to get into data science. So just quick overview of all of these things. The very first step is obtain, right? I mean, it's data science. Obviously, you're going to need data, right? So obtaining is just this idea of getting data. Then you have scrubbing. That is basically cleaning up the data. Something I want to talk about a bit more. I know it doesn't really make sense how do you clean up data, but if you want to think about it formally, it's just something like, let's say you're noting down the ages of every person who's walking in today for the session, right? you can definitely have a typo, right? Instead of 19, you can end up typing, I don't know, 1p or something like that. There could be typos everywhere. So that kind of thing, you need to sort of ensure that these kind of mistakes in the data don't happen, because then what happens is the computer, it just learns whatever you give it. So it's going to learn those mistakes, it's going to repeat those mistakes. Moving on, you have explore. Here, the idea is you have the data, you want to sort of become friends with the data, right? And this is where all the statistics part of it comes in for all of those who are interested in the maths behind it. Then you have model. This is the famous fancy part. This is the machine learning part that everybody's hyped up, everybody wants to go in. And finally, you have N for interpret, which don't ask me. I know it doesn't make sense, but it is what it is. The final step is basically just getting the results and putting them in a pretty way so that anybody and everybody who looks at it can understand what's going on. So I'm going to start off with obtain. So like I said, it's a data science project. You're going to need the data first, right? Now, where do you find data? It's not, it's not a simple question. It's not like saying, where do you find pizza? You say you go to Domino's, you go to Pizza Hut, tons of different options. But where do you find data? So, I mean, the first very obvious answer here is the internet, right? Uh, it's pretty much got everything. You can, like, there's a ton of information out there. You just need to know where exactly to look for it, right? So the kind of data that most like uh, you'll be working with mostly when you look for data on the internet is going to be something called CSV. That's comma separated values, which is essentially just an Excel sheet. But instead of having all those rows and columns, you're going to have all the different things separated by commas, right? So that's basically what a CSV is. And there are some other formats as JSON and TSV, and let's not get there because it's not very important. Now, moving on, let's say you tried on the internet, didn't find anything, right? Sad. But you don't find that, nice little data set like I was talking about. So CSV is a very nice data set. It's a dream. Somebody has already put in that data for you in a nice little table and column format. What more could you want, right? But if you're not able to find that, then another very popular option is connecting to APIs. That's basically short for application programming interfaces, which sounds like a very scary term, but it's very simple. It's something actually you see happening around you constantly. So for example, if right now you were to Google the weather in Delhi, right, you're going to get quite a detailed report of the different weather conditions and forecasts and everything. Now, I know that Google isn't currently in the business of, weather data, right? I mean, so far, maybe that changes. So they get this data from a third party, and you're going to see this actually when you Google it. And if you notice, right, they're going to have this little source written at the bottom where that's where they're getting the data from. So how exactly did this happen? This basically happened is that they went to that website. They said, "Yo, I need weather details for this," and the website gave it to them. This whole process happened automatically, programmatically. That's why this is called an application programming interface. It's just basically a way that apps talk to each other to get data. I can't. That's how I'll put it. And finally, a common option that you're going to see if you're working in the industry is a database. Now, database is basically, I'm not going to go much into it. You can think of it as like a collection of Excel files. Um, but of course, since it's the industry, they want to make it sound really fancy, so you can do CRUD operations on it. That's basically create, read, update, and delete. Yeah, so you can create a file, you can read a file, you can update it, and you can delete it. So that's about it. So sorry, these are the three main sources, right? Most of the data that you'll be looking for, you'll find it somewhere in there. So this is the obtaining phase of it. The fancy word for it is data engineering. In order to be sort of getting into data engineering, some stuff that you really, really must know, I would say, is SQL, that's structured query language. It's basically a way of talking to the computer and asking it for data. And if you already know SQL, you want to sort of upskill yourself, then you can move on to more advanced stuff. You can move on to big data, and big data is essentially nothing. It's just like when the data becomes too huge for you to handle. And for that, you have a lot of different stuff like Hadoop and Spark. So you can start from there. So that's it for the obtaining part of the data, for the data engineering part. Next, you have the scrubbing part of it, right? Um, Again, like I said, I gave you an example there about the age thing, right? So maybe you put in the age as 119 instead of 19, or maybe you put in the gender as I don't know, X instead of M or F, right? Or put the name in as Bill instead of Jill, whatever. You can make tons of mistakes, and that these mistakes essentially are going to make your data dirty, right? Now, yet another example is going to be like basic techniques that are involved under this is essentially data selection for starters. So what does that mean? It means it's you using your, yeah. Oh, sure. Okay. Right. So for the first thing that you have sort of is data selection, right? It's essentially looking at the columns and it's deciding which ones you need, which ones you don't need. You can also use the columns in order to make new stuff. That's called feature engineering. So you know, if you feel that your data is going to do more usefully, like it's going to be more useful for your predictions, if you're taking the average of two columns, then you can use that, create a new column and feed that to your model. So all this comes under the scrubbing part of it. But one thing in particular that I'll really like to talk about that I feel you absolutely must do in scrubbing is answering this question: is 10 a lot? Now, 10 depends, right? You can't really say. So is 10 10 rupees a lot? Not really. Is 10 murders a lot? Debatable, I guess. Yeah. So that's the idea here. You're gonna give your machine learning model some sort of context, right? So how exactly you give that context is through something called data scaling, right? I'm not gonna go much into it. I'm just throwing around these terms. I like you can uh, start looking at these terms. You can just Google them and you're gonna get an idea. But essentially, scaling is uh, you get in a range of the data, right? You sort of making your data make sense within that particular range. So, like I said, 10 murders versus 10 rupees. So, you want to sort of give that context to your machine when you do data scaling. So, in order to sort of be good at this step, you should you should be good at, I would say, if you have zero programming experience, then you can start out with OpenRefine. That's a really good framework for doing this. If you're already familiar with Python or R, then that's pretty much all you need to know. And if you want to take it a step further, then I talked about Hadoop, that's about big data, right? So you can also use MapReduce here. It's basically Hadoop's sort of scrubbing data wala part. Moving on, you have E for explore. Again, like I said, this exploration part is you becoming friends with your data, right? And how do you become friends with anyone? You ask them questions, you get to know about them. That's pretty much what you're doing here as well. So, I've been saying data a lot, and data can be of many types, right? You can have your numerical data. You can have like 1, 2, 3, 4, 5, 6, 7. That's numerical data. You can have categorical data. That's something like, I don't know, your blood group, for example. You can only have it to be O positive, O negative. There's a certain fixed number of blood groups defined. You can't really have ones that are not in that category. You can also have ordinary data, that is like data that naturally has some ordered categories, like you agree with something, you disagree with something, you're neutral about something, etc., etc. So these different kind of data, you need to look at these values. You need to sort of group these values, and you're supposed to reduce what kind of data you have, and you need to treat each of these differently, right? Now, this is where the statistics part of it comes in. You have to basically do some math and draw some graphs. It's not really that tough, to be honest. But essentially, the idea here is that you want to look at the different relationships between the variables that are involved, right? So, I mean, think about it. If you're building a model, right, and you have a lot of things, lot of columns, lot of columns are called features, by the way. So you have a lot of things that you're sort of giving into the model, but only some of them are useful. Then you would obviously want to remove those ones which aren't that useful, because they're just they're just increasing your time, and they're just wasting the machine's time, they're wasting everyone's time. So this is where establishing these relationships becomes very important, because what you can do effectively is rule out certain stuff. So for example, let's say you have a column that talks about the gender, and you have a column that talks about pregnancy, for example. Now, male people cannot be pregnant. So that's something you can use. That's something you can use to cut down on your data, right? Because you already know that male people cannot be pregnant, right? So essentially, when you sort of reduce the data, your machine understands better. It already, it's going in with the assumption that, all right, male people cannot be pregnant. Great. And therefore, you're reducing the potential for errors as well. So again, here, the kind of stuff you need to learn in order to be good is it's nothing much. It's nothing different from the scrubbing step. If you know Python and R, then you should be familiar with the NumPy modules and the Pandas modules and matplotlib, etc. And the equivalent of that in R is ggplot2 and dippler. And if you want to sort of really get into this, really dive deep into it, then you can look at inferential statistics. Like that's the sort of a branch of it that deals with this explicitly. Moving on, you have model. This is the machine learning stuff that's super, super popular. Everybody's doing this. And, however, at the end, data science is a fake aspect here. This is not the whole, you've seen that already, right? This is just one part of it. And to be honest, it's one of those parts of it that's not, I would say, not very widely, like, sort of utilized in the industry. I think that's the right word here. So you want to have roles that look for ML engineers, etc., etc. But essentially, it's going to be like, if you're a data scientist, I expect you to do this part of it, right? So you're not going to find many standalone roles dealing with exactly just the machine learning aspect of it. That's not going to happen. So when it comes to machine learning, you can have these two sort of ways in which the machine learns. So one way is called supervised learning, and this is where you basically making it easy for your machine to learn, right? So for example, if you're trying to build a model that when you give it an image, it can tell you whether that image has a dog or a cat. Now, in order to teach this to your machine, you're going to show it a bunch of images of dogs, a bunch of images of cats, a bunch of images of both, neither, etc. And you're going to tell it, okay, you know what, this image contains a cat, this one contains a dog. So, when it looks at a new image, it's like, ah, right, this one contains a dog, because it learned that. So this idea is supervised learning, wherein you see you sort of explicitly telling the machine, uh, what the data you're feeding it, what exactly it is. Now, what if that's not the case? What if you're sort of going in another direction? And that's called unsupervised learning. And I'm going to give you an example of this. So, right, imagine that you're sort of visiting a foreign country, right? And there you're going to some sort of subsequently, right? You're going to a fruit market, right? Now you see a stall there that's selling a fruit which you're not able to identify, and you obviously can't read it because you're in a different country. So, but you have your eyes, you have your smell, you can sort of deduce what it is. You can look at the nearby vegetables as well, maybe, and see, this is lying with this, so maybe it's a fruit, it's not a vegetable, etc., etc. So, what you've done here is that even without knowing what fruit it is, you have deduced what fruit it is, right? So, this concept is unsupervised learning. So, a classic example of this is, for something like customer segmentation, right? So you give your model the different sort of genders and the location, ages, incomes for all the people that are coming in your store, and consequently your model will return these various clusters of different people who are visiting your store. So this thing is called clustering. It's one of the very popular unsupervised learning methods. But essentially, yeah, these are the two broad categories. Within these categories, you have a lot of stuff. You have regression, and like I said, you have clustering, etc., etc. Not going to go much into that again, but I'm going to tell you that in order to get started with this, if you want to start out at a very basic level, then scikit-learn is a really good package, and consequently in R you have Carrot. That's also a really good package. And if you want to take it one step further, then I would say you look at evaluation metrics, which are essentially just ways of seeing how your model has performed, right? So one thing that you're already very familiar with is something like accuracy. So obviously, if a model is doing well, it's going to have a good accuracy, right? It's going to return a lot of results that match with the results you have. But it's a bit more nuanced than that, because let's say your data is something like that has 99% of the people, it says that they have that particular disease. For example, let's say you have a disease prediction model, and the data that you have, it just says that 99% of the people have that disease, 1% don't. So if your model predicts that 100% of the people have that disease, then it's still going to be 99% accurate, right? But that's not really tangible, because your goal when it comes to disease prediction is that you diagnose every person, you diagnose that 1%. That's what becomes really important then. So, like I said, it gets a bit more nuanced than that. So that's where you're going to look at stuff like confusion matrices and advanced scores. And finally, if you want to, if you're already familiar with those, then I would say you shift your attention towards hyperparameter optimization. Very fancy word. It's just, it's just like basically like you can think of this whole model as a recipe, and any recipe has like a very fixed number of things, right? So only 2 cups of salt. Any more, it's going to taste weird. So hyperparameters are basically these ingredients. Tuning them ensures that you have just the right amount of them. So that's basically it for the modeling part of it. Finally, you have the interpreting part of it. This is, I feel, one of the most underrated aspects of the data science pipeline, right? Because at the end, whenever you're working in any sort of company, your goal, the reason why you're doing data science, is going to be to solve some sort of business problem, right? And you solve that problem. Now you need to communicate it such that they understand what the hell you're talking about, right? They're going to be business people. They're not going to be knowing all those statistics and all the machine learning stuff that you know. So if you go to them and you say something like, "I achieved an F1 score of 0.76 using uh, SVMs and Bayesian optimization to tune the parameters," they're not going to understand shit. So you need to sort of dumb it down, I would say, to the point where anybody and everybody who's looking at the data can understand what's going on. And the way you do that essentially is by using a lot of pretty graphs and curves, etc., etc. And another aspect of it is that you're able to communicate these things to the people, right? So this means presentation skills. Again, it's not something that a lot of people really appreciate. So, data scientists need to be good at communication, because if you're not able to explain your results properly, then they're pretty much useless. So, this data visualization thing, on a very basic level, you can do it in Python. I'm sure a lot of you who are familiar already do it. You do it using Seaborn or ggplot, matplotlib, etc. But if you want to sort of take it one step further, you can look at data visualization tools like Tableau and Power BI, very, very popular. And if you want to take it even more further, I would say you focus on improving your communication skills. So, yeah, I mean, that was, I basically told you what every data science project looks like, right? And it's fine if you didn't, if you didn't understand much of it, that's fair. Because I basically just made you skim through this whole book of data science, what a typical project looks like. Now, the question that's on your mind is, where do you begin? And the answer is, you can begin wherever you want. So, most people, the general trend is going to be that people are going to begin at model, that's the machine learning part of it, because it's the fancy word. So that's a really good place to start, though. I'm not going to say that's not where you can start. Andrew Ng's course is, it's pretty much a very, very popular, very standard course that everybody does. So that's a really good place to start. And then from there, you can, sort of move back in the pipeline or move forward in the pipeline, depending on where your interests lie. But there's no hard and fast rule as such. You can also start with interpreting the data. If you're not very, program it, like if you're not really in the programming, or you don't really know about Python, you want to stay away from that, then you can actually start with interpreting the data. So that's going to be building these visualizations, like I said, in Tableau and Power BI when you have the data. So that's again something very useful. It's exactly what business analytics does, to be fair. And if you're not, you can also start with the obtaining part of it. You can start with data engineering instead of modeling it, because I would say data engineering is like one of the toughest things in this whole pipeline. So once you have that, then it's pretty much a smooth curve from there. So a lot of different places to start, and you can pretty much start wherever you want to. So I guess at this point, Raj, I think I'll stop for a while before I move on to strategy consulting. I can take a few questions if yeah.
Absolutely. I will. I'll ask you a few questions that have come in the chat.
Mm,
Now, someone has asked how to get into data science. I guess you just answered that, so we can let that rest.
mm.
Another person has asked, would you like to comment or share your opinion on IITM's online degree program on data science?
See, I'm going to make a somewhat controversial opinion here, but I personally feel that data science is in that stage wherein you don't really need a big name behind it, right? It's a very small, like it's still in its infancy in India, so you don't need to do any sort of university programs or anything of that sort to get into it. So obviously, if you have the resources, if you have the time, go ahead, invest in it. But I would say that there's you can learn much more on YouTube for free. You can learn much more on Coursera, edX. There's a lot of resources out there that I
Yeah.
feel are better than these, because at the end, online certifications, they don't really matter. It's all about the projects you do, I would say.
Yeah. Another person has asked, which should one prefer in their undergrad, data science or actuarial science?
Hmm. That's a good question. So I would say, I mean, again, first things first, it depends on your interests, right? So actuarial science is more to do with the finance angle of things, and data science is more, well, general. But in general, I feel that for undergrad especially, it's better if your degree is more general, because you don't know what's going to happen in college. So I took electronics and communication engineering, and I regret it. But the point is that it's better than if I had taken a very specific aspect of communication engineering. If I had taken very specifically semiconductors, for example, for my undergrad, then that would have been absolute hell for me, because I would have been forced to study a subject in so much depth that I don't even really like.
Yeah.
So it's better, the more general your undergrad is, the better it is for you to explore, I would say. So I would prefer data science over actuarial science here.
Yep. Uh, Another person has asked, will a PhD in statistics be helpful in data science?
Very helpful.
Yeah.
I mean, one of the things that you sort of see in data science is that people, like I said, it's actually it's still in its infancy. So people don't realize sort of what the skill sets required are. So a lot of the companies that you're going to see are going to have, you need a computer science degree, you need masters in statistics, etc., etc. So it's good to have them. You don't need them. They're going to make your life easier. So I'm not going to say ki mat karo.
Yep. Uh, Another person has asked, online certificate plus projects are enough to get internships. I guess you just answered that. They are enough. Another person has asked, so machine learning is a very vast stream. For someone to be industry ready, how much should someone learn to get to that level?
For someone to be industry ready, don't do the thing that everybody out there is doing, I would say, because thing is, machine learning, man, I agree with you. It's a very vast field, but you need to understand early on whether it's the field that you really want to dive deep into. So if you want to really just drill down on machine learning, right? If you're enjoying it, that's it. That's the only case when it should happen. That's the only, like, if you're having fun with machine learning at its very basics, where you're learning all the regression models and random forests, etc., then you should keep diving further. You should potentially go into deep learning. You should look at reinforcement learning, maybe even automated ML. But if you're not enjoying that aspect of it so much, then I would say you shift your focus to other aspects of the pipeline, and you try sort of building a general portfolio, because that I feel is the very sort of rare thing in data science. So because I personally, many people machine learning wale craze mein I just got in initially. But if you have a very diversified portfolio, right, that's very refreshing for a recruiter to see, because most people just machine learning pe drill down rehte hain. So if you're not enjoying machine learning that much, then I would say you expand your portfolio. But if you're liking machine learning, then I would say you dive down to deep learning ke level tak. You don't need to know reinforcement learning that much, I would say, and till then you're pretty much good.
Yeah. Another question has come. Difference between data engineering and data science.
Yeah, so like I showed you this whole pipeline, right? So data engineering deals with the obtain part of it. It deals with the O part of it, and this would basically mean writing a lot of SQL queries, no SQL queries, maybe using some tools like cron jobs or Apache Airflow. Whereas data science is pretty much this whole pipeline. So mostly when people say data engineers, you're going to have a lot of technical work, a lot of technical work. Like 95% of your work will be technical. But when people say data scientists, you can say it's going to be a bit more skewed. You can call it, I would say, uh, 70-30 in like technical versus non-technical aspect of it. So it's a bit more balanced that way.
Yeah. Next question is, do economic graduates have an advantage in data science?
Yeah, I guess. I mean, economics graduates. Yeah, I guess you can make a point there. See, essentially, it's all about selling yourself, to be honest. Uh, Whatever you do, if you're able to sort of relate data science as a very integral aspect of it, then you're doing fine, which shouldn't be that tough to do because data science is pretty much everywhere. So if you're an economics graduate, right, so there you have a lot of projections and forecasting revenues, etc., etc. So that's data science. Essentially, that's data science. So you can use that to sell yourself. I am an electronics and communication engineer, so I did a few projects wherein I had to, simulate certain uh, mobile communication systems, for example. So there also the new trend is that using data in order to allocate frequencies, right? So obviously, if a user is calling user B more, then you would want to keep the line ready between these two. So I use that to sell myself. It's all about, I don't think your degree matters much. It's about how you sell yourself with your degree, how you link the job with your degree.
Another question that has come in is, how much experience should someone get as an internship in this field in India? Because opportunities here are really limited.
Yeah, that is a problem, to be honest. I mean, opportunities are limited. You're going to probably get rejected a lot. I mean, I know I did. Hopefully, you don't. But yeah, the idea is that how much exactly I cannot quantify it in a number for you. Because, like I said, it's about try doing as many as you can. And then when you're in that interview room, it should come across that you've done it. So, rather than doing, 3 or 4 low quality internships. And when I say low quality internships, I mean there are certain companies out there that just gonna give you like one basic regression task as an internship and go ahead take your certificate. Certain companies out there who you have to pay to get an internship. So rather than doing these kind of 4 or 5 internships, do one very solid quality internship that's gonna have a much better impact. So as long as you're sort of out of your internship, as long as you sort of have learned something that's industry relevant, then even one internship is a lot in my opinion.
Yeah, so another question that has come is, can we become a data scientist just being familiar with Python and required Python libraries?
You can start your journey that way, uh, but actually, what happens is you start that way, but later on, when you're working in obtaining data, for example, then you're not going to have these libraries be of much use. You have to, if you have to say get data from Google Ads, then you're going to have to actually write down the scripts in order to extract that data. So it's a good place to start. मतलब just people keep on saying लोग चढ़ जाते हैं machine learning पे without covering the basics first. They don't take a bottoms up approach. You don't have to take a bottoms up approach. You take a top down approach. You start with the libraries, and then as you sort of gain an understanding of the subject, you understand what's happening behind the scenes. You understand what exactly that library is doing. So as long as you have an understanding of that, then yeah, I mean that's I guess enough.
Another question that has come in is, how much time should one spend on statistics?
See, I was fortunate in that I had a semester long course on it, though I did not take it seriously. Uh, but still, I had some sort of basic understanding before I really got into it. But one thing you'll understand when you look at statistics is that when you're looking at the basic level of statistics, right? Looking at distributions and stuff, you want to understand that it's not really going to be that time consuming. I mean, obviously, it's a whole well. You can keep on going as deep as you want. But when it comes to the machine learning equivalent, when it comes to the data science equivalent of what you need, I would say you spend like, let's say you dedicated 3 months to learning it, 3 months to learning data science. I would say you can spend 1 or 2 weeks on statistics. And Baki fil later on, as you move on, you're going to learn new stuff as you keep doing it. So learning by doing is the best way of sort of picking these things up. But 1 or 2 weeks is a good for, a basic level of statistics to start with.
Yeah. One question from my side. Uh, I didn't tell you this, but in my college, for some reason, I took computer science with specialization in big data analytics. That's what I got, and that's what I took. So, number one, what is the difference between big data analytics and data science? Because these are the two terms that I keep on hearing. And number two is any tips for someone who is just getting into this?
So I personally feel that you sort of hit the nail on the coffin with this, because this is like uh, computer science with big data analytics is a really, really good specialization if you're interested in this domain. So the main difference again, it's like big data is what's happening in the industry. Abhi. So when you go to the more technologically advanced companies, like I'm talking Amazon or Google or those kind of things, they're going to be working with big data, right? So that's where you're going to have a real advantage, because तुम्हारे course में cover होगे all the big data techniques. Data science is, I mean, there's no difference as such. Again, big data is just, it's a lot of data. Like they're the 5 V's of big data. I'm sure you've heard of them. But uh, that's the trouble. It's like it's too much data to handle. So what's happening is that data science is sort of becoming overshadowed by this big data in the technologically advanced firms. So the main difference as such, I would say, is just like the way you handle the data. In big data analytics, it's different. In data science, it's different. But at the end of the day, it's, if you're good at big data analytics, then you're good at data science. Not necessarily true the other way around. So you'll be fine there. And what was your second question? Yeah, I mean, to be honest, I'm not in a position to give you tips here, because I myself have actually started getting into big data recently while I'm working for Crime Free Bharat. Then that's where I've sort of been introduced to it. And yeah, I mean, as such, I don't really know what to tell you there. But from what I've experienced so far about big data, is that the process is pretty much the same, although it's more complicated. Like Hadoop key installation in itself is hell, as opposed to something like, SQL or something like that. But basic core principles same here. So if your fundamentals are clear, then I think big data isn't going to be as challenging.
Yeah, cool. Thanks for that. Another person has asked, could you share your journey on how did you start with data science? Because I've done the same thing, that is top-down approach. Straight away started with data analytics and machine learning, and while diving deep in, I used to wander around Medium articles. So, what's the proper way to approach this to minimize the time in learning?
So the proper way to approach it, I mean, I didn't approach it properly, but like, yeah, I mean, in my first year, I was just exploring different kind of things. I was doing a lot of different courses. So that's when I sort of first came across this. Didn't take it very seriously. But a bit later on, when this whole COVID pandemic started, that's when I sort of, again revisited it. So I started where I since when most people start with the modeling part. I started with Andrew Ng. I did his machine learning course. I did his deep learning course. Then I tried finding a course that covers everything, rather than looking for specifically an interpretation kind of course. Like looking specifically for Tableau, for example. So that's actually reflected in my. Actually, I guess I'll just, yeah, no, library. So I sort of took a very overview kind of course, right, that covers all of these different things, data engineering and Tableau. I didn't understand shit. I would say I retained about 25% of what I did. But yeah, essentially the idea was that I get used to the pipeline, the whole pipeline, at as early as stage as possible. So that's reflected. That's when I, once I did that, once I had a basic idea of the whole pipeline, that's when I started applying for internships. Uh, I applied for internships on Internshala initially. That was a mistake, uh, but because Internshala sucks. But anyways, uh, the thing with the internships there is that most of them they give you assignments to do at the start. So I'm sort of happy that way that I took that route, because what ended up happening was that by doing these so-called assignments, which are actually the work, they do that in on Internshala. They give you the whole work that you're supposed to do as an assignment. So by doing that, I ended up building a few projects that I could then list on my resume. And like you said in the question, you sort of pondered upon lot of Medium articles, etc., etc., getting lost in this whole sea. I did too. I guess that everybody sort of has that. You're supposed to get lost, थोड़ा थोड़ा बीच बीच में. But essentially, supposed to also come out. ज़्यादा नहीं घूमना. And yeah, when you do these projects, right, that's when I would say the most learning happens, because you have some sort of structure in what you're googling and structure in what you're doing. So I did a few of those projects. That's when I got my first internship. Uh, that was basically with the automated machine learning. So I worked for a bit there, and from then on it was simpler, I guess. The first one is the toughest, I would say, to break into. From then it gets a bit easier, just a bit, though it's still pretty much hell. uh, and yeah, I mean, as for a right way to do things, if I could do one thing differently, I don't really know how to answer that, to be honest. Like, you're supposed to, once you start a course and you do your project, you're going to get lost while you're doing that project. So if you have a mentor, then that's a good thing. I didn't have a mentor. So you could maybe, if I could change that, I would have a mentor. I would join a community like Unify and get the help of some friends. And that's going to help you, become a bit more streamlined. So learn as a community, I would say. That's going to help you out.
Uh, yep. So another question that has come in is, how long would it take me to become a good paying data scientist?
It's been 1 year for me, still not good. So I guess it's pretty long.
Yeah, cool. Now I have one question for you that is completely unrelated, but now it's been 45 minutes almost since we've
Hmm.
been doing this. Are you free? Because I know that you've prepared for strategy consulting and internships. So do you want to continue, or should we have this in another
Uh,
session or something?
Actually, with strategy consulting, my portion was lesser only, so I guess we can continue with that.
All right, cool.
Or yeah,
We'll go on if you have to.
cool. Yeah. So yeah, that was it about data science. Now I'm going to move on to strategy consulting. Uh, Similar question to what I asked initially. What comes to your mind when you hear strategy consulting? This one, it's a bit more complicated, because data science is a very huge term in engineering colleges. Consulting wasn't, at least from like when I was sort of looking into it. I hadn't heard of it. Right, I had to do some research on it. So that's, when I did my first 1 or 2 data science internships, then that's when this whole consulting concept popped up in my campus with this idea of share leadership program. I don't know if your colleges have that, but it's like a widespread network of colleges, and essentially they teach you consulting for free if you make it through their selection process. So I applied for that, and that was my introduction to consulting. And if any of you are familiar, you're going to be having heard of a lot of these terms, right? You must have heard of M&A and fundraising and whatnot. So consulting, again, much like data science, it's a very complex domain. You don't really have one right place to start, one wrong place to start. So when it comes to consulting, the main idea in all of these essentially is solving problems. Businesses hire consultants so that they come in and that they solve their shit. That's what consultants do, to put it simply, and they charge a hell lot of money for it. So, how exactly do they solve these problems? I'm going to sort of walk you through a consultant's approach to any problem, and that's what's applied in all of these big firms, McKinsey, BCG, Bain, whatnot. And yeah, it's just like once I walk you through the process, I'm going to explain you why these consultants are paid so much. Because if any of you are not familiar with consulting or anything, just do a quick Google search of on how much consultants are paid. You're going to be shocked. Uh, they paid a hell lot of money. Obviously, they work a lot for it. Not as much as investment bankers though. Those guys are the real grinders. But yeah, I'm going to sort of walk you through the problem solving process for consultant. Much like I showed you a data science project, this is what a typical consulting project looks like. And yeah, hopefully again by showing you this whole pyramid, hopefully you have some sort of understanding of how exactly to approach a consulting project. So consultants solve, how do they solve these problems? They do it by using a lot of fancy terms. So consulting is one such field that you're going to realize, once you sort of start learning things, that it's going to have a lot of fancy terms, very fancy terms. But then you look at the definition of those terms and you're going to think, what the hell? Because it's something very basic, but they sell it in such a great way that it appears really fancy and sophisticated. And I would say that's what a large part of consulting is. It's selling. It's selling yourself as intellectually superior to the person who's hiring you. That they need your help, and that's how you become a great consultant. You become a great consultant when you have the ability to uh, convince the other person that they need your help. They're gonna die without your help. So that's again. So I'm gonna just start with the typical approach to a problem. So let's say you have a very simple problem statement that my restaurant is not profitable. Right? You have you're working towards this restaurant. You're working for this restaurant, and he comes to you. You're a McKinsey consultant. He's gonna come and tell you my restaurant is not profitable. Now you're gonna probably say that's very vague, right? I mean, uh, your restaurant is not profitable. Where do we start with that? And that's the thing. अगर उन्हें पता होता है, if they knew why the restaurant is not profitable, they wouldn't have come to you, right? If they knew why the restaurant is suffering, they would have solved the problem themselves. So that's where consultants come in. They help solve the problems that the business people are not able to solve. So one way of sort of doing this is that they take the problem and they break it down into smaller sub problems. This figure that you have in front of you is what is called an issue tree. Because what you're doing here is you have a main issue and you're breaking it down into smaller issues, right? So this is the issue tree. You can see you started from something very vague, like my restaurant is not profitable, and now at the bottom you have a list of different possible causes behind it, right? It could be because you know you need to fire some workers. Maybe that'll help solve the problem, or maybe you need to change the cuisine. That's going to solve the problem, etc., etc. So one thing you will notice when you look at this issue tree is that all of these suggestions, they're I mean, for starters, they're pretty much all you can think of. Like I personally cannot think of any other suggestions that aren't covered in these suggestions, right? If you can, then that's great. Good going, a good consultant. But yeah, so it's pretty much, I would say, exhaustive. And you can also observe that these suggestions are pretty much unique. They're different to each other, right? So when you have something like changing the cuisine, that's very different from something like shifting to a less spicy neighborhood. So you have MISI here. What is MISI? Fancy term. Mutually exclusive, completely exhaustive. So mutually exclusive means that all of these different things, they're all exclusive. They're different from each other. Completely exhaustive means that this whole issue tree, it spans the whole thing. Like this is the list of possible things that could be the cause behind the problem. So this is the first step. Any consulting problem you want to get, you want to try breaking it down to smaller problems that you can actually do something with. Because just restaurants not making profits, that's not really something you can do a lot with, right? So you break it down to smaller problems. Then moving on, when I say breaking it into smaller problems, it's not as simple as just increasing revenue and lowering costs. Although sometimes it is as simple as that. And then I would say this meme is still very unrealistic because there should be at least two or three more zeros in the bill. But yeah, this is pretty much it. So you have that. Next, you have something called hypothesis and analysis. So I'm going to sort of give you an example. I'm going to walk you through the whole thing here. So let's say you have the issue that does India have enough resources to make a graphene based battery? It's a very general question, right? What's resources? So you can break down resources, right? Resources could be the natural materials required, there could be the industries required, etc., etc. So let's focus on one specific resource. Let us look at, do we have enough qualified engineers to make these batteries? Because obviously it's not something that anyone can make, right? These are very specialized batteries. So that's one smaller sub issue. Next, you have something called a hypothesis. Hypothesis, in simple terms, is tukka, or the English version of it, guesswork. So this is where you sort of want to make a guess, right? Without knowing anything, you want to guess. Yeah, I mean, India has a lot of universities, a lot of institutions, and there's some very high quality of engineers here, right? And you want to say that on the basis of whatever you know, right? Like, let's say I study in matlab, bits and I see some good quality engineers around me, so I'm going to maybe make that claim, but that's not going to be the claim coming from somebody else. So that's again going to be dependent on your perspective, but that's the thing. It can be wrong. You can be wrong. The hypothesis can be wrong. It's just going to give you a starting point. You now have some direction. Ki you said ki yeah, you want to have enough qualified engineers because you have enough qualified institutions. So next you have analysis. Now you need to prove or disprove your tukka, right? So this is where you're going to look at data and you're going to see India की university ranking क्या है respect to the world, etc., etc. So you're seeing like maybe once you look at this whole thing, you want to understand why I have both data science and consulting, because consulting is essentially just an extension of data science, right? So you look at the analysis part of it. It's you looking at data, right? And the stuff above it, that's you basically taking the problem and breaking it down. So I guess you're starting to understand why we have these two together in session, because strategy consulting is essentially the business version of data science, I would say. So yeah, that's a basic idea of how any strategy consultant would approach any sort of problem. Any problem out of these, that's how they approach it. But yeah, so before I get to that, I told you why consultants get paid so much, right? So firstly, they get paid a lot because people aren't willing to acknowledge their own flaws. No business likes to say ki we messed up, right? Secondly, it's because businesses cannot at times see what's actually going wrong. Because I mean, from an outsider's perspective, it might be very evident, but within, you can't really tell, right? So that happens at times. That's also an issue. And finally, they get paid a lot because they know how to really present the data well. So this is something that I again talked about in data science, about how communication skills and data visualization is a very important and a very underrated aspect of consulting, of data science. So that's a very same thing for consulting. So if you go to any sort of, you look at McKinsey or BCG or Bain, you look at their presentations, you're going to realize that maybe the data that they have is not necessarily something very out of the box. It's not necessarily something that you can't find off a quick Google search. But the way they present it in such a easy to digest, in such a small, like, to the point manner, is that that's what they get paid for. They condense information down so that anybody can understand it. And this is one of the most highest paying professions in the world. So that's about it for the consulting aspect. Now you must be wondering, much like you did for data science, what's a good place to start? Here I would say you just need to start. There is no shortcut to it. You just need to pick up a project. Don't go any online courses or anything like that sort. Maybe find some solved case studies, right? Those are very easy to find, and go through them and try understanding what how they are approaching the problem versus how you're approaching it. And that's just about it. You need to learn by doing in this, because there aren't really going to be many courses that feed you information, because there isn't much information to feed in the first place. It's about looking at a problem and solving the problem. So yeah, this is where you start. So like I said, this is going to be short, so I'm open to questions now.
Yeah, so I don't think we have a lot of questions in this space, but let me check. I have some questions personally, though. Yeah, so the only question that I have is now you're the third person that we've had here who has talked about consulting and strategy consulting and all. Uh, the question that I have is that everyone says you don't need to learn something, but then how do you learn this thing? How do you get projects? How do you pitch for your first project? in the first place.
Yeah. So you need to start. There are a lot of places, I would say, wherein there is stuff where you need to make an impact, essentially. So there are a lot of communities out there on LinkedIn, on Instagram, wherever you look. So I personally am also part of one such community that's called Impact Consulting, right? And what these communities do essentially is that they do pro bono projects, fancy word for free. So they do free projects towards sustainable causes, towards causes that make an impact. So for example, I recently worked with an organization that's dealing with suicide prevention, and I helped them, come up with their business model and come up with a nice launch plan, etc. So these sort of organizations, they don't tend to have like there isn't a requirement that you need a lot of experience or anything of that sort. They have a very diverse group of people working there. So, like I said, my last project, I was working with a McKinsey consultant. I was working with a very, very senior, like 30 plus years of experience CEO of some company. So there's a huge, huge variety of people there. And at the same time, I was also working with some high school students. So joining these sort of pro bono consulting initiatives is a really, really good place to start, I would say. As for learning it explicitly, I would say there are a few courses out there. I personally didn't take any online courses for this, to be honest. But if you want to do some courses, I'm sure there must be some out there. But best way to learn, in my opinion, is by doing a project. What kind of project? Um, I did something recently that was basically just looking at the different ed tech players, right? So I did a competitive analysis of those guys. I also recently did something like looking at urban companies' business model. So you just look at all these big companies, all those creds and all those Zomatos. You look at their business models and everything, and make nice, pretty presentations, show that off. That's pretty much it. That's how you want to get attention, I would say.
Uh, so the crux of this is that you need to do a bunch of pro bonos, a bunch of projects with these
Yeah,
communities.
bunch of pro bonos and a bunch of, yeah, I would say pretty presentations from bulk projects. That's it.
Yeah,
Yeah.
cool. That's cool. Now you're working at Ernst and Young. You're doing an internship as a marketing consultant, right? So, number one, how did you crack that? And number two, what is your job as a marketing consultant?
So as to how I bagged that, again, LinkedIn. So basically, came across a post saying that they need somebody. I applied, and then there was this task that they handed out initially, wherein I guess I can actually share that maybe. Give me a second. Yeah. So basically, the task though was this. I had to come up with a different way of selling a certain product that they have. Yeah. Visible now? Great. So this was the task. I had to sort of design a new campaign for them. So again, you see, it's not really much. It's just basically trying to build a pretty slide, and that's what I did. And that was the task. Then they had these 2 3 calls. Let me just open my presentation once again. Then I go there. Yeah. Then they had these 2 3 calls. So the first call was generic HR kind of call. They were asking me about where do I want to do further education, etc., etc. Then one call was grading me on my resume. Grading is, I mean, you get it, right? They were sort of asking me everything I did. So, that's why it's important that you don't lie on your resume because that can get you in trouble. Yeah, I didn't just say, but yeah, they do that. They want to make you go through your resume line by line in order to catch any liars because I guess people do that a lot. And finally, there was this case study wherein I had to devise a market entry strategy for a tech firm that's it's not like Byju's or an academy who are sort of dealing with these K-12 education, right? It was more so for like dancing classes. So
Hmm.
dancing classes online. So for that, I had to come up with a market entry strategy. So that was my case study and that was my interview. And उसके बाद I had one informal call asking me about availability and everything. So that was it. So yeah, again, the process is going to be pretty much similar, I would say. most important thing is that you're good with the case study interviews. You need to sort of have a nice approach to that. You need to keep talking with them, letting them know what you're doing, especially in online interviews because उधर तो बहुत ही chaotic है. So you do that. And now that I'm here, it's not been a while. I mean, it's been like 2 or 3 weeks. And as to what exactly I'm doing, there's like a bunch of projects going on. I personally chose one wherein I have to conduct primary market research. In simple terms, that means giving surveys, asking people for opinions about how people's perception of online courses has changed from 2020 to 2021. Because you have a lot of data that talks about, उसके पहले का, right, कि कोरोना से पहले versus कोरोना के बाद क्या हुआ.
Yeah.
But you don't really have data that talks about abhi in this second wave of lockdown, what's happening. Are people
Hmm.
motivated enough? I know I'm personally not at all motivated
Yeah.
as opposed to last year. So sort of need data on that, and then you're going to use those results and going to use some tools to make those results pretty and present it. So that's my project for now. It's going to end in like a week's time, a week or two. Then I'm going to get a new project. Yeah.
Yep. That sounds cool. Uh, all right. I guess we can move on to the next one.
Sure. So, I mean, I didn't really have much get for this part, the getting internships part. I guess I'll share my LinkedIn for this. Give me a
Yep,
second.
absolutely. I've shared it in the announcements and everything.
Uh, yeah, but like, I mean, like, I just need it for like a screen sharing kind of thing.
Yeah, yeah, definitely.
They didn't really prepare.
Also, if you are watching this on YouTube, his LinkedIn is in the description as well. You can check it out from there.
So is it visible?
Yep, it is.
Great, great. So I'm just gonna start with this. This was my first data science internship. It was at Proton Metric. It's a very, very small infant stage kind of thing. Still very small. And yeah. So basically, here my work involved automating ML pipelines. So basically, the whole data science pipeline that I showed you, right? I automated that. So now it became like somebody comes and they give me the data set. I'm going to do everything for them. I'm going to make all those 5 steps automated, and they're just going to get the final results out of that data set. So that's what it did. You have these like you can choose what kind of model you want, etc., etc. So, I mean, it was a very initial product. They were just building an MVP. I personally was also in a position to only build an MVP because I didn't know shit. But we still managed to, achieve top 40% across multiple CAM competitions, which I felt was pretty nice because, uh, it's, uh, it was my first time doing something like this. So, yeah, how exactly I got this internship? I got it after a lot of rejections, like a lot of rejections. So problem is that they don't even tell you your like they ghost your resumes most of the times. Very few companies will come ahead and tell you that you've been rejected. Try your luck elsewhere. You just get rejected here. So yeah, I got a lot of rejections. But when I finally got in here, I had an interview call, and he asked me some very basic questions. I would say because I guess he understood that I've just begun my journey into it. So he asked me stuff like what is overfitting or how is IDF different from PCA and everything. So this might sound like a lot of complicated jargon, but if you actually look at any sort of machine learning course, these are very, very basic things. So he asked me those. I was honest in the interview. Whenever I didn't know anything, that's the way it always is with me. If I don't know anything, I don't waste that time. I just say I don't know it. So I was saying that, and yeah. So I guess he took a shot with me, and that was my first one. Then I had another one that I didn't really put up here. I removed it after a while because that was yeah, not a good experience to be honest. But it was basically in the domain of computer vision, wherein if you guys are familiar with OCR, optical character recognition, that's basically like we were given these different documents that were in the PDF format, and we had to sort of build a search engine on them. So anybody who Google's not Google's, anybody who searches for that particular term, they get a list of those different PDFs containing that text, which is not as simple because these PDFs they did not have machine readable text. So I don't know how to explain this exactly, but you can think of it as like most of the PDFs that you get when you search on Google, you get them because they contain those terms and the computer is able to find out those terms. However, most of the PDFs that we had were essentially sort of like images. So usme the computer cannot locate the text easily. So you need to convert that image to text before you do that. So I did that text image to text conversion part. Then I worked on the search engine kind of a part that was using I don't know how to pronounce it, Kubernetes or something like that. Kubernetes, something like that. And the reason why I removed it from here is because they said they're processing my stipend and they're processing my certificate. I send them monthly emails, still not here. So, ouch. Uh, anyways, so that was that. And then this one was my PS1 project. PS1, for those who don't know, it's like a Bitcoin compulsory summer internship thing. I was one of the very few people who had a good project because then mostly PS1 is just like, they give you presentations to make and reports to write, sort of the grant work. I got a very good project wherein I had to build a chatbot for National Institute of Rural Development. And I mean, chatbots aren't exactly, you could say they aren't exactly related to data science, but there is an element of NLP involved in them. That's natural language processing. So yeah, but to be honest, in Google Dialogflow there wasn't much work that makes your life really simple. If you ever want to build a chatbot, Dialogflow is a really good option. It's very simple to use. And yeah, we sort of me and the other guy who was working on this, we built it right from like the starting to the ending point. And yeah, so this is one of those projects. Like this is one of those internships that like I said, it's all about selling yourself, right? So you're gonna find this in both my data science resume and my consulting resume. On my data science resume, it's more focused towards the NLP part of it, natural language processing part of it. On my consulting resume, it's more focused towards stuff like this, right? Or stuff like this. So CSAT is nothing, it's just customer satisfaction score. It's basically how many people are happy with the chatbot. So that's the difference. And this one was this one is, I would say, my best data science internship so far. It's the one where I learned the most because here basically what I had to do was I had to build a marketing dashboard for them in Tableau. So this is where I learned Tableau as well. And here I had to get data from Google Ads, Facebook Analytics, etc., etc., and then put that in a nice little dashboard. So I learned a lot here. How I got this exactly, again, there was an assignment involved at the start. I completed that so quickly that he was shocked. Uh, like, I mean, I didn't, it wasn't like a timed assignment. It was more like, he had given us 7 days. I completed on the day he assigned it. So that's why he was really impressed with that. And then the interview was pretty much a breeze, to be honest. And that was that. Then these two ones that I'm doing currently, I already talked about the EY one. The TRG one, it's again, it was very simple to be honest to get in once he saw my resume. So the guy who sort of, this is the guy. So I had actually applied for this position before, and he had sent me that message before here. Yeah, this message, just wanted to know all these kind of things, and I told him, and then he ghosted me. And then I applied to the role again. I guess this one was on January 29th, and then I applied again on March 8th. He sent the same message, and I told him scroll up, and
That's
so
oh my God.
I guess he got that, and then it was a pretty fun interview. And yeah, so that's how I got this. So this was again in consulting, right? Consulting, mein, it's like I did a lot of stuff when, like I said, like I told you, right, for pro bono things. So
Yeah.
I'm part of the consulting club here. This is the pro bono thing. So I did a lot of these things, and that really helped me in my candidature here.
Hmm. Yep. How do you manage two internships at one time? Because you're doing two right now, right?
Yeah. I mean, it's like I've given up on my degree, right?
College. Yeah.
It's all in
That's
God's hands, no?
yeah. Because I guess looking by your LinkedIn, you're doing internships since last March, like
Yeah.
continuously, and that's the only answer I was expecting. You've given up on college.
No, no, but they understand, like if I tell them ki I have some sort of assignment, yeah, I have my exams early, so they understand that. So they tend to give me some leeway that
Yeah,
ठीक रहता है,
that's interesting.
you know.
Uh, cool. Any You're done, right? We can kind of end this.
Yeah, yeah, go ahead, please.
Cool. I mean, I don't have much to say. Uh, I have one question that has come in the chat. Uh, I'm looking for an handwriting recognition model for OCR. Could you suggest a resource for that? Also, how to read research papers?
How to read research papers? Okay, I guess I'll answer that first, and then I'll come to your OCR question.
Yep.
Because how to read research papers is very, very important, especially if you're really going into machine learning, right? Like I answered a question before, if you're really into machine learning, then you need to know how to read research papers. So there are a few websites out there. I don't remember the name exactly. Maybe if you Google it, you'll find it. Which actually sort of have these research papers that are highlighted, and they have these little summaries on the top. So I personally, I loved those. Those were really, really great because they made my life much easier. But in general, what I felt is research paper you cannot read on a computer, at least in my opinion. You need to sort of print it out, and you need to sit on a table with uninterrupted, no disturbances, just full concentration. Sit with the highlighter, sit with the pen, and you need to mark the hell out of it. So you won't understand shit on the first read. Then you read through it again, and then you read through it again and again. So after 4 or 5 times of you reading it, that is when it's going to make sense for the first time. Then the second time, that number is going to drop down to 3 or 4 times. And now if you give me a research paper, I won't struggle as much. So reading them takes time, I would say, but you need to be. I would suggest that you print them out because मेरे से online नहीं पढ़ा जाता. I cannot read it online even now. It's very distracting. Print it out, get a pen in your hand, get a highlighter, and that's the way to approach that. As for handwriting OCR recognition tools, Amazon's Tesseract is very, very good. Very good, matter of fact. Like I was personally firstly trying OpenCV, right? That's typically a go-to library for OCR. But it wasn't really giving many impressive results, especially in data that has a lot of tables and stuff. So if you have very simple data, if you have something like just lines of text, then you can very easily go ahead with OCR, with OpenCV. But if you have this complicated data that has a lot of tables and a lot of diagrams, etc., then you can go ahead with the Amazon Tesseract, and I believe that is free up to a certain number of calls per minute. So that's a very, very solid resource. It's very surprisingly accurate, I would say.
Yep. Cool. I have another question. Sharad Kumar has asked, can you please share your resume?
Yeah, I mean, share it in the sense like, please screen share it.
Maybe. I have no idea. Is it there on your LinkedIn?
Uh, Not really. No, I don't think so. Yeah, I guess I'll screen share it once. I'll just share the one. Which one do you want to see? Both or
I guess both. Like, no
yeah.
harm.
Is it visible, Abhi?
Not the resume, it's just LinkedIn.
Sure. Right, let me stop sharing that.
Yep, cool.
Yeah. So this is again the thing with resumes is that you need to have one grand resume, one master resume, sorry, and then you need to have one specific to the role. So this is the one that I sent to EY. So again, the
Okay.
position's title was marketing strategy. So you can find that term pretty much everywhere: marketing strategy, strategy. So this is going to be different if the role was something like, I don't know, competitive analysis. Then I'll be changing these descriptions accordingly. But yeah, one thing you want to observe in these projects is that they're all led by action verbs, stuff that I did, and a lot of fancy language. Consultants eat that shit up, use a lot of fancy language. Uh, so again, so like look at something like this, right? Very fancy words, but essentially it's just as simple as they wanted to explore a new market, and I helped them explore that new market. But you need to sort of sell it in such a way that उनको लगे कि wow, मतलब मेरे बिना तो मर ही जाते वो लोग, ऐसा type. So this, then you look at something like I don't know, this, like look at this, like reducing of either all that happened was that we suggested key people work from home and come to office instead of everybody just coming to office.
Yeah.
Look at how we sell it. So that's what I'm saying. It's all about selling. Consulting is sales with extra steps. So
Hmm.
if you sell yourself, then that's pretty good. That's sad. I'll show my data science one now.
Yeah, sure.
Let me see where I have it. It's a mess. Oh, no, this. Yeah, is this visible?
Yeah, it is.
Great. So, yeah, again, so in data science, it's a bit different. Here, you want to sort of what happens. I'll tell you one very common mistake in technology related resumes is that people tend to make it very technological, right? The trouble with that is that most resume screenings, they're also HR screenings. So those guys don't necessarily understand a lot of it, right? So remove this one, this Arbus one, because I didn't really. This hasn't been updated for a while. So remove that. But if you look at something like this, for example, right? So here you're gonna see if I wish to, I could have made this very technical. I could have talked about certain NLP things that I used, etc. But the idea here was to just have enough technicalities such that if anybody who's experienced gets an idea of what I'm doing, but it shouldn't be technical to the point where a HR person is not understanding what I'm doing. So here, getting that right balance becomes very important, wherein you have both business and technical ka sort of mix 50-50. Because unlike coding domains, right, either what in data science there isn't really, like, unless you're applying for Amazon or any of those big firms, there people tend to have that technical knowledge. But if you're applying to other sort of smaller firms, then the data science division isn't exactly a different division. It's मतलब वो या तो कंप्यूटर इंजीनियरिंग उसके अंदर ही आएगा, कोडिंग वगैरह के अंदर, या will come under business. Yeah, so this is sort of a hybrid of those two things. So your resume also needs to be a hybrid of those two things.
Uh, so another person has asked, could you drop the link to your resume so that I can refer to it later on?
Yeah, I guess I'll upload it on my LinkedIn. Yeah, drop a link to it as a Google Drive बना दूँगा. हाँ ठीक है ठीक है, I can do that.
Just make it DM it to me on LinkedIn. I'll put it in the description, or you can just put out a LinkedIn post.
Yeah, yeah, I think I'll DM it to you. Drive पे डाल के I'll do
Yep,
that.
absolutely, surely.
Yeah,
So, all right. I guess it's time to end this then.
sure.
Uh,
And
yep. Any closing remarks? Anything from your side?
yeah, I mean, I would say pretty much showed you data science, shown you consulting. They're very related domains, and if you're interested in any one of them and sort of need any sort of help, I mean, I'm not really an expert on any of these things myself, but if there's any way I can help you out, then please feel free to reach out to me on LinkedIn, right? Uh, I'll try my best. I'll maybe help connect you to other people as well who know much more than I do. And yeah, just good luck. It's very tough to start with, but once you begin, it becomes really fun, I would say.
Yeah. Do check out his LinkedIn. It's in the description. So yeah, connect with them, ask him questions, do whatever. All right. Then I'll end the stream once again. Thanks for coming, Akshat. I loved it, and so did a lot of people. We had a low viewership today, but yeah, a lot of people have stuck by. Cool.
Yes.
I'll end the stream now. Goodbye.
Bye.
Ooh.